Hello there. Let's start doing some advanced switch things, like VLANs or virtual LANs. But before we get carried away with VLANs, let's talk about broadcasts because they're the blessing and scourge of LANs and one of the main reasons why VLANs exist. So first of all, we need to understand what is a broadcast domain. A broadcast domain will be any part of your network where a layer 2 broadcast will propagate. Remember, the broadcasts we discussed in previous videos are going to have a destination MAC address of all hexadecimal Fs or 48 binary ones if you prefer the binary. And when a switch sees this, the switch will flood the broadcast out of all of its interfaces apart from the one it came in on. And that's under normal circumstances. Also bear in mind that a switch has got no way of knowing at the moment, until we start doing VLANs, where a broadcast belongs, who it's meant to go to, stuff like that. It just follows the very simple instruction, everyone must get this message. The good news though is routers, or any layer 3 gateway for that matter, are going to break up our broadcast domains. So let's see one in action with that topology from our switch video. So we've got our router in the middle, we've got a hub on the left, we've got a switch on the right, and broadcast domains are very easy. Everyone's part of a broadcast domain. The only thing that breaks up the broadcast domain at the moment is the router. Now hubs naturally broadcast just because they're layer 1 and they relay a signal out of all interfaces. And the switch, it will forward a broadcast if the destination MAC address is all Fs, or a unicast if the switch does not know the destination MAC address. Now if you watched the previous video on the switches, you might be thinking, but wouldn't ARP have already found the destination MAC address and caused the switch to learn it? Yes, it would have. But if the switch was power cycled, the MAC address table will be flushed and empty, whereas the client's ARP tables will still be populated, especially if they're laptops. They wouldn't experience a power outage for a moment. So there is possibilities where the switch might not know the destination MAC address, but in some way the clients do. Now, why is this such a problem? I mean, this network's pretty small and simple. Well, that's it. This network's small and simple. Let's scale this up a little bit. So we've got several switches and a router to act as a gateway for this LAN segment. But for whatever reason, we've decided to put 4 different departments on this set of switches. Now, the problem is if the computer in department A over there sends a broadcast, it will hit that switch. That switch will then propagate it out of all interfaces, including to people who are not in department A. That broadcast hits that core switch in the middle, and guess what? It also goes out of all interfaces. Now the router's going to probably ignore it because it's going, oh, layer 2 broadcast not meant for me. But the other switches, they are going to do what switches do, which is forwarding the broadcast. So it's going to go out of all those interfaces to all those computers. And chances are, that person who sent that broadcast probably just intended, or if they didn't do it, the software on their computer did, it probably just intended for that traffic to only go to people in department A, not B, C, and D. So this is a visual of the problem, but there are a couple of other ones as well. So what are they? So as we saw, it creates a lot of unnecessary traffic, which is going to be a waste of bandwidth, obviously. And is also going to be a waste of time for the recipients processing that traffic that is never going to be meant for them. But there's also a bit of security risk as well. There is the possibility that somebody in a different department could do a packet capture. I know I would. And there's also going to be greater visibility if an attacker has a rogue device in there for them to do reconnaissance. And then malware generally has a much easier time spreading when everybody is on the same layer 2 network. If we can break it up into separate IP subnets, we can have a much easier time with keeping that malware isolated and contained. No guarantee, but we're going to have an easier time of it. And in general, we're going to have challenges making our network more optimal, because it's going to be harder to prioritize traffic when everybody is in the same IP subnet or common layer 2 network. So let's go and use VLANs to fix this. So the basics of VLANs. First of all, a virtual LAN, or virtual local area network, we love our acronyms in networking, allows for a logical switch topology to exist on top of a physical one and have different ways for traffic to forward through it. Now you can also have multiple virtual topologies on top of that one physical topology, which is why we say VLANs plural. And the logical topology can separate devices from one another. So let's visualize this. Scaling down that problem we had earlier, we're going to have a couple switches, department A, B, and C, and a router. Now, the problem is, at the moment, they're all in the same physical and logical topology because we haven't done VLANs yet. So if I wanted to separate department A, B, and C users from one another, I'd have to change the network a bit by replacing that core switch with the router and putting department A, B, and C on different switches. Oh dear, we have to move a person in department B and C around so that now they are properly isolated, which might not be convenient or suitable for whatever this organization is doing when it comes to office layout and workplace layout. So going back to our main points, we can achieve the broadcast domain separation like we did physically with that router without having to recable that network. Now let's go and get some terminology dealt with and then we'll jump in. First up is 802.1q. That is the IEEE standard, and it's an open standard implementation for VLANs that all enterprise and small business network vendors will support. You may come across some vendors and their proprietary implementations of VLANs, which is all well and good, but now you're bound to using that vendor for all of your switches, at least for that LAN segment. Might be better to go with 802.1q. It gives you a little bit more mobility and helps avoid vendor lock-in, which is something you want to consider with enterprise networking. As wonderful as a given vendor might be at the moment, they might not be as great in the future. Remember, companies are not your friends. They're in the game to make money. We're also going to talk about untagged traffic. Now, we're going to get into it properly, but what's going to happen is VLANs and our switches are going to impose something called a VLAN tag, which allows the switches to know which VLAN traffic is associated with. And if traffic has got no VLAN tag, we call it untagged traffic, and it's basically just an ordinary Ethernet frame. But when we do put a tag on it, we refer to it as tagged traffic. Now, in addition to this, we're also going to talk about these things called access ports. These will be switch ports that will be sending and receiving untagged traffic. I'll explain where they are and what they're about when we're doing a diagram. And then we have trunk ports. Sometimes you might see them called tagged ports, but it's the same thing if that's the name being used. And these switch ports will be able to send and receive tagged traffic. Now, with all that in place, let's go check out how VLANs are going to help us out. So we move that topology over a little bit, so I've got space on the left there to write stuff. And the first thing you would go and do is you would go and create the VLANs. Shock and horror, right? Now, once you have decided to do that, you're going to be doing this on each of your switches. And when we are making our VLANs, we're doing it by number. So I will be running commands or clicking on console options in a web console that will say VLAN 10, VLAN 37, VLAN 42, whatever. We make and identify them by numbers, not by names. So we're going to have VLAN 10, 20, and 30 here. For no other reason than this is just a bit of a habit for me. But one of the reasons why I like to do 10, 20, and 30 is maybe I want to create some special VLANs for Department A. So I can use everything from 11 through to 19 and think, oh, that's part of Department A. And 21 through to 29 for special things for Department B. So I do like to space my VLANs out a little bit. But you do you, or follow the best practice that your workplace is using. Now, you can create up to 4,096 VLANs. So you've got quite a bit of room to play there. You can get more, but for now, we're just doing normal VLANs. And a special thing to understand is VLAN 1 exists by default. If a switch supports VLANs, VLAN 1 will exist by default, and all interfaces will be access ports for VLAN 1, which once we've looked at what access ports are all about, you'll understand then that basically that particular default status or configuration, if you want to consider it a configuration, is going to effectively negate the presence of the VLANs. So let's assume I've run through all four of those switches and I've created VLANs 10, 20, and 30. Now, next thing I'm going to want to do is I'm going to want to go create my access ports. Now, my access ports are going to be the interfaces I want to use to connect my end devices to the infrastructure. So let's go and make all of those connections to those PCs to be access ports. And what access ports will do for me is they will be receiving untagged traffic from that end device, because obviously I don't expect these client computers to understand 802.1q or VLANs. And those access ports will be adding a VLAN tag to that traffic so that it can be associated with that VLAN. Now that means I'm going to have to make these access ports members of those VLANs. And then when it comes to sending out traffic, the access ports will remove the VLAN tag before it sends the traffic out to the end device. As I said a moment ago, we do need to make sure these access ports are members of those VLANs. So let's quickly mark each access point with which VLAN it's part of. So we've got those two access ports being part of VLAN 10. We've got that access port being 20, that one being 30, that one being 20, and that one being 30. Great. So this is going to start separating these 6 PCs into the 3 different departments now. Good stuff. Now let's have a little mini transmission taking place. Let's say we have that computer there sending a broadcast. That traffic will travel untagged to the switch. When it arrives on the switch will add a tag or a label that says this belongs to VLAN 10. The switch will then check, do I have any access ports that are part of VLAN 10 if it's a broadcast? And it will say, yes, I do. Let me send that traffic out. But remember, when it goes out of that interface, it's got to go out untagged because most computers don't understand VLAN tags. So they would think that extra data is corruption or some crazy weird stuff that they don't know how to deal with. But that worked out nicely because both people that are in Department A are on the same switch. What about when people that are in the same VLAN are on different switches? Well, we have to do something a little bit cooler there. And that thing is setting up some trunk ports between the devices. So trunk ports will be set up between the switches on both ends. So on either end of a cable, I need to make sure that each switch has got the port set up as trunk ports. Cool. Now the trunk ports are going to carry all specified VLAN traffic that has been tagged already by an access port as it arrived. Now I emphasize the word specified because with a lot of the enterprise vendors that I dealt with, you have the option to be selective about which VLANs are allowed to travel across the trunk port. Or you could specify all VLANs are allowed across the trunk port. The option is yours. For now, we'll assume that our trunk ports have been set up to carry all VLANs. I'm not going to start applying restrictions yet. If I've got these trunk ports able to carry all VLAN traffic as long as it's tagged, let's see what happens if we get somebody, let's say in Department C there, this computer, to send a broadcast for Department C's VLAN. So as always, that broadcast travels along, but it's untagged at the moment until it arrives on the first switch's access port. When it's on that switch goes, okay, it arrived on an access port that's part of VLAN 30. So let me label it as part of VLAN 30. So now that the switch has labeled that stuff as being part of VLAN 30, it will then see, do I have any access ports? Yes, I do. I've got an access port over there, but that access port is part of VLAN 20, not 30. So it's not going to go out there. Then the switch says, do I have any other interfaces that allow VLAN 30? Yes, I do. I have this trunk port over here. So it sends that traffic out of that trunk port, but it travels with its tag so that the next switch that receives that now knows that this thing belongs to VLAN 30. That call switch can now check, okay, do I have any access ports? And are they in VLAN 30? Well, that switch doesn't have any access ports. And it does have trunk ports. So it can send that traffic out of those ports. Off it goes. Now I'll show you what we do with the port from the call switch to the router a little bit later on. But for now the traffic goes to those other 2 switches that are providing access to the end users. And remember, when it travels out of all those interfaces, it travels the tag for VLAN 30. Now that traffic has made its way to those switches go and check, okay, it's tagged as being part of VLAN 30. Let's look at the switch over here first, on the left. It says, oh, I've got 2 access ports, but both of them are in VLAN 10, not VLAN 30. So it's not going out there. Now let's check out what that switch will do. That switch will see 2 access ports, but it'll see that one is in VLAN 20. So it's going to say, no, that's not going out there. It sees that access port as part of VLAN 30, so it says, oh, I can work with that one. So then it starts getting ready to send that traffic out. But remember, when it goes out of an access port, the access port's got to take away the tag so that it becomes untagged traffic. And that is how VLANs are able to keep the traffic separated. It looks like it's not going to actually keep that broadcast isolated, but it saves us at the last minute when it says I'm not going out of ports that are not in the associated VLANs. Great. But we've achieved logical separation or isolation, but what about when people in these departments need to actually talk to each other? Well, now we've got to think about doing VLAN routing. So let's go through the concepts of VLAN routing quickly. VLANs are logically separated layer 2 networks, and that means we can have different IP subnets being used in those VLANs. Therefore, we need to do routing. Great stuff. Routing between VLANs will either require us to use a router, or we're going to use a layer 3 switch. And I will get into what is a layer 3 switch just now. First though, I want to show you VLAN routing via the router. So as we said, each VLAN becomes its own IP subnet. So that means we can have VLAN 10 being 192.168.10.0, VLAN 20 being 192.168.20.0, and VLAN 30 being 192.168.30.0. Now there is no need to correlate the IP addresses and the VLAN numbers. If you ever do see this done in the real world, it's probably being done to simplify the management or possibly maintain the last shred of sanity for a network engineer. Now, what we could do is we could go and have an access port per VLAN to separate interfaces on the router, like that. There are problems doing it this way though. Firstly, the router doesn't come with that many interfaces, and if I want to increase that with expansion cards or WICs, as we call them, WAN interface cards, it can get very expensive to do that, and we do have more than 4,000 VLANs at our disposal. So this method is not going to work out very well for us. So we could do something a bit better, like making that one connection to the router a trunk port. Now if I do that on the switch side, then I can do something very cool on this router. I can do something called a sub-interface. It's a virtual interface on the router. And as I said, we trunk from the core switch to the router, and we create virtual sub-interfaces on the physical interface that that connection goes to. So whatever that interface is called, I can create sub-interfaces underneath that one. Now, once I've gone and created those sub-interfaces, I can go and give them IP addresses so that those sub-interfaces can act as default gateways. And I will also tell those sub-interfaces to terminate specific VLANs. Now, word of warning here though, there may be a bit of extra configuration you need to do depending on the network vendor that made the router. But you'll have to check that vendor's documentation, courses, material, whatever it is that you rely upon to know how to work with that vendor. So let's put 3 little dots on that router to represent those sub-interfaces that I would have created. And what we're going to do is we're going to have a source and destination for some traffic now. So we're going to have somebody sending from the 192.168.10 network to that person in the 192.168.20 network. As always, the traffic leaves the personal computer untagged, arrives on an access port, and gets tagged as being part of VLAN 10. Now, the sender would have gone through the effort of finding out the destination MAC address as the router's MAC address. Yes, the router will have a MAC address. And the switcher's MAC address table will then know, okay, I need to send the traffic out of the trunk port. So out we go. But because it's a trunk port, it's got to travel with the VLAN 10 tag attached to it. Now it's on the core switch. The core switch will do the same thing. It'll see the destination MAC address as the router's and know to send it out of that trunk port that takes it to the router. It arrives on the router's physical interface, and then the router goes, I've got no config on my physical interface, but I've got these virtual sub-interfaces. Let me ask any of them if they know what to do. And the sub-interface I create for VLAN 10 will step up and say, yes, I'll take that. And it'll also rip off the VLAN 10 tag, because the router just treats this as an ordinary IP packet. It just happens to understand how to recognize an 802.1q tag and remove it, at least when it's coming in. The router will then do its normal routing operation, looking at source and destination IP address, deciding what to do with it. And it'll move it to the appropriate outgoing interface, which happens to be a sub-interface under the same physical interface that we set up for VLAN 20. Now, being a sub-interface that works with VLAN 20 and being the outgoing interface, it will impose or add the VLAN 20 tag. When I say it terminates it, it doesn't just kill it. It just acts as an endpoint. So if something's going to go into that VLAN, it'll add the VLAN tag so it can work. And now that router and that corresponding sub-interface can send that packet out. This time though, it returns to that core switch with VLAN 20 tag on it. And now, because the router would have gone through the effort of finding out the destination MAC address of the recipient, again through ARP, the switch knows, okay, it must go out that interface, and it's a trunk port, so it better go out with its VLAN 20 tag. That traffic now arrives on that access switch, and that access switch will see the destination MAC address it saw on that interface before, and see it's an access port. So when it sends it out, it will strip away the VLAN 20 tag because the end user PC probably doesn't deal with 802.1q very well. And voila, the traffic is now on the recipient. Beautiful. But what if I want to do this with a layer 3 switch? Well, let's check that out. Layer 3 switches, also known as multi-layer switches, are both a layer 2 switching device, and they also have an internal routing capability. If I were to visualize that for you, you can imagine the switch being a switch, but logically inside it's got a division, and in that division sits a little logical router. And we can have traffic logically sent to this little mini router inside from any of these physical interfaces that the end users might be connected to, or even trunk ports even. And this will allow our switch to perform some routing operations. Now, why would you want a layer 3 switch though? Well, there are some situations where it's going to be a lot more efficient to do a layer 3 switch rather than layer 2 switches and a dedicated router. But for now, let's see how will the layer 3 switch handle the routing. Well, let's diagram it out. Now, almost the same diagram, but please note the router is gone, and now we've got this layer 3 switch here. Some vendors might use a separate symbol for a layer 3 switch. Usually what I do when I'm doing a diagram is I'll normally just label it somehow as a layer 3 switch. For now, the little red star can do. So we're going to go create virtual interfaces on this layer 3 switch for the VLANs. We often refer to them as a VLAN interface, at least that's the common name. And what we're going to do is indicate those little interfaces with the same types of 3 dots we did on the router there. And now I can go and set IP addresses on those VLAN interfaces as though they are default gateways. If I have to do any additional configuration, that will vary by vendor. But some of the vendors I deal with, it's as simple as just set up VLAN 10, 20, 30 on the switch, make your trunk ports, whatever you need to do, normal VLAN setup. And once you've done that, you have the ability to immediately create a VLAN interface, and you just have to link up the interface by saying interface VLAN IF10. Can be that simple. Other vendors, it might be a bit more involved to enable the layer 3 switch capability and the VLAN interfaces. So it does vary by network vendor, I'm afraid. Now, let's see what's going to happen if we do some transmissions. Let's use the same source and destination as earlier, and chances are you're probably working ahead of me right now and you're probably making some very good guesses about how this works. The traffic begins on that source computer, travels untagged as always, arrives on the switch, and gets tagged as being part of VLAN 10 because that's the VLAN that access port is a part of. Now, the destination MAC address for the default gateway will be the core switch's base MAC address. All network appliances have MAC addresses so we can communicate directly with them. And switches are no different. They have an internal MAC address so that if I need to speak to that switch specifically for whatever reason, be it remoting into it, or in this case it's a layer 3 switch, it has a MAC address I can target. So that MAC address would probably be in that switch's MAC address table for that interface. So out it goes the trunk port, and remember when you go through a trunk port, you've got to be tagged as part of VLAN 10, or at least a specific VLAN. Now, that traffic arrives on that switch. That switch sees, oh, it's destined for the gateway, and the way it knows that is it sees its base MAC address as the destination MAC, and that switch then passes it to the appropriate VLAN interface. The way it knows that, the VLAN interface is tied to VLAN 10 in this case, and the traffic is tagged as being part of VLAN 10, so it knows where to put it. Now, it's going to do the same thing as the router. It'll strip away the VLAN tag, it'll perform a routing operation and move that traffic to the appropriate outgoing interface, and get ready to send that out. As it goes out the appropriate interface where the recipient's destination MAC address would be known, and that traffic, as you can imagine, will be tagged as being part of VLAN 20 this time, just like it was with the router. So that when it arrives on the next switch knows this belongs to VLAN 20. As always, the access switch sees the destination is accessible on an access port, and it will send out the traffic without a VLAN tag. Pretty straightforward. Now, a concern you might have is this is all well and good. This is really cool. This is neat. But now, how are we going to be able to get traffic routed to other networks where we actually are using a router? Well, we can integrate layer 3 switches with routers. So if we have that layer 3 switch there with the lazy man symbol for a LAN segment there, and we put a router on the other end, and there are some other networks that router is going to get us to. We could be relying on OSPF for the rest of the routed infrastructure. Now, what I normally like to do is I will go and create a VLAN. Like, for example, I might go create VLAN 99. And then I would use 192.168.99.0 as the network address for that LAN segment. And I'll go and assign .1, for example, or 192.168.99.1 to that router's interface there. I'll then go create a VLAN interface 99 on that layer 3 switch and give it the IP address 192.168.99.2. Good idea when you do that would be to ping it to make sure it works. What I would have to also do is make that an access port for VLAN 99. Otherwise, it should work fine, and we should be able to ping the router or the router ping that interface either way. If you're using a good layer 3 switch, it should support OSPF, which means I go and set up OSPF as I would on a router. I go and set up network advertisements for link state advertisements for network 192.168.99.0. And that should allow me to then also have the network advertisements traveling back and forth, and that VLAN interface and that router will discover each other. They'll become friends and they'll begin exchanging routes. Now, to do the proper routing, I'd also need to make sure I tell OSPF running on that switch to also advertise the network addresses for the respective VLANs that it is acting as a gateway for. So that, in effect, I'm letting the little logical router in here talk to the actual router. But you know what? Any routing protocol could be used. You can even use static routing as well, if you so wish. I would probably go with OSPF though, because I'm only doing 3 VLANs here at the moment, so not too much work for static routing. But you never know how that's going to grow and evolve, because that's one of the big benefits of VLANs, is that they are very scalable and flexible. So I'd go for a dynamic routing protocol just for my sanity again. Not that I have much sanity left anymore. Now let's have a look at VLAN uses. What are they good for? So first up is security. With VLANs, we are able to create separate IP subnets that need layer 3 forwarding, basically routing, to get traffic back and forth. Now, if we have a situation where layer 3 forwarding is present, it allows us to do things like traffic filtering via an access control list, which we'll cover in a later video. We could use traffic filtering via firewalls. We could also have an easier time identifying where traffic comes from. So if anyone's up to mischief, I can look at the source IP address and have a rough idea where they are in the organization. And it helps limit the spread of malware, as we said earlier. And I could even use it as a way to place wireless LAN traffic in a dedicated VLAN. And I can also use VLANs for easier and cheaper guest isolation, making sure that guest networks, whether they be physical or wireless LAN connections, are in their own dedicated VLAN. Ideally, I would personally like to have a dedicated physical network for guests that is separate to staff members, so that the guest doesn't have an opportunity to try and escape the VLAN, for example, and hop onto a staff network. But that costs a lot of money, and the organization might not be keen for that. So using a VLAN to isolate guests is not bad. Just be aware, though, there are techniques that hackers can use to do VLAN escape. But another benefit we have is we get better network performance. As we said earlier, when the broadcast domain is reduced in size, it means fewer devices are processing broadcasts that will never be useful to them. So, bonus! We also have the opportunity to prioritize traffic more easily, because we could apply quality of service, which we'll touch on in a later video, to a VLAN. I could dedicate VLANs for voice over IP, so that again I can prioritize voice over IP, possibly even dedicating a bit of bandwidth to it. I could also do VLANs for IP security cameras to maximize the quality of the footage. And I can do VLANs for VIP users. Please note, VIP users don't mean the fancy big shots necessarily at the workplace. It normally means users that are very important to that operation of that organization. You will have people that are mission critical and essential, and people that are not. And VLANs for wireless LANs also again help us with improving performance, which we'll talk a little about when we do the wireless LAN section. We're also going to benefit from a simplified design and support for our network. We're going to be able to move LAN segmentation to a logical approach, which means simpler physical topologies can be achieved. And believe me, simpler physical topologies are way easier to make redundant. So we're going to have an easier to manage network that is also going to be a bit more reliable if we start introducing some redundancy, which we'll discuss in another video. Then we could also make troubleshooting a lot easier, again, because a simpler network is easier to isolate faults in. And fewer pieces of hardware means fewer physical things to check for if we suspect a physical fault. And we can relocate devices and users from one LAN to another via a configuration change rather than having to run around and move them to a physically different device, which is pretty cool from a support perspective. And then finally, we can experience cost savings because the port density and forwarding capacity of a switch is far greater per dollar or whatever currency you prefer than a router's. Now don't get me wrong, routers are great, they're really fast, but per port and overall forwarding capacity of a router is generally lower if you use the same price point to compare a router's performance to a switch's performance. At the end of the day, it's not unusual to see switches with 16, 24, or even 48 ports used in a user access area. Whereas to find a router with that many interfaces, those are not cheap and they're very, very specialist and more likely to be used by service providers. So routers are generally going to be less ideal than switches for VLANs and LAN segmentation. Routers are generally better at dealing with the physical media and encapsulation standard change between a LAN and a WAN connection, such as Ethernet to whatever your service provider is using as its layer 2 WAN standard. Also, you can use bottom tier enterprise switches that support VLANs as long as they're managed. Through my experiences, almost every enterprise switch, even if it's at the bottom end of that vendor's product offering, will support VLANs as long as it's this manageable switch that I can log in and apply configuration to. And this will actually help us a bit because it also means my router's performance can be focused on traffic forwarding between different parts of a building or the campus or forwarding traffic to my ISP. So all of that performance can be for that. And then the switch takes over the worrying of moving traffic around and forwarding between people in the same part of the building or campus. So a fantastic way to get the most value for money out of a switch and a router by using them in ways that you play into their strengths rather than trying to make it an all-in-one device. Now, I'm hoping that gave you a good overview for how VLANs work, because that's all I want to cover with you for the basics of VLANs. We are probably going to revisit VLANs a little bit more in this course because it is part of the Network Plus syllabus to go a bit beyond this now. However, I would like to say thank you for watching. I hope you enjoyed it and you have a better understanding for VLANs. And if you have any friends, family members, colleagues, peers, etc. who are also interested in Network Plus, don't be afraid to share this video with them. Otherwise though, I will catch you in the next video.